We're going to talk about factoring the difference of two squares. And in that topic, there's quite a few words that you really need to understand or remember what they mean. First of all, the word factoring. Now, we've had factoring before. An example of factoring a trinomial, we factor trinomials would be if we had m squared plus 10m plus 16. And when we factored a trinomial, first of all, we said that nothing can be common in all three terms, which there isn't, and the coefficient, or the number in front of the square term, has to be a positive 1, which it is. And then we'd write down two sets of parentheses. Now the second sign was plus, which means they're both the same, and then we'd look at the first sign to determine that they're both pluses. Now, since they're the same sign, I want two factors of 16 where the sum is 10, and that would be 8 and 2. And then I'd break down m squared to m and m. And that's what we've been doing for the most part, is factoring trinomials. Now, let's look at the m squared. Now, we recognize that m squared actually is a perfect square, because m times m is m squared. Think of numbers that are perfect squares. For example, 100 is a perfect square because 10 times 10, or 4 is a perfect square. So we also have the word squares in here. So we're going to factor what we mean by squares. So squares are where you can break it apart so that you can multiply something times itself to get that. For example, m to the 6 is a perfect square. Why? Because m cubed times m cubed would give us m to the 6, right? You add the exponents. Another perfect square would be a to the 4th. Why? Because a squared times a squared gives me a to the 4th. So those are perfect squares or squares. Now the other word that you need to remember what it means is difference. Now difference means subtracting. So keeping all these things in mind, factoring and squares and difference, we're now going to continue and talk about the factoring the difference of two squares. Let's take a look at example 1. Now, first of all, is this a trinomial? No, it's a binomial, but we can factor it. And really, factoring these type of things is a lot easier, really, than factoring a trinomial if you recognize what you have. It's really easy to factor this if you recognize what type of binomial we have. This is called the difference, because they're subtracting, of two squares. Because x squared is a perfect square. Why? Because x times x is x squared. 4 is a perfect squared. Why? Because 2 times 2 is 4. So if you recognize that you have a binomial, you should say, hey, this is really easy to factor, or in other words, break apart, because it's the difference of two squares. So the difference of two squares always breaks into a plus and a minus. Always. So in other words, if you recognize you have the difference of two squares, it always breaks into a plus or a minus. Now, we've talked about before that I could easily have a minus and a plus there. The order doesn't make a difference. Now, break x squared apart. What's x squared? What's the square of x squared? Well, it's x and x. And then what's 4 break into? What times itself is 4? Well, 2 and 2. And I'm done. This is all I have to do with factoring this, because if I check it by FOIL, let's see, multiply the first terms as x squared, multiply the outer terms, let's see, 2 or x times a negative 2 is a negative 2x, multiply the inner terms, 2 times x is a positive 2x, and multiply the last term in each, 2 times a negative 2 is negative 4. And then I notice that the middle terms cancel out, because the negative 2x plus 2x, they cancel, and what do I have left? X squared minus 4. So again, factoring the difference of two squares is really easy, but you got to recognize when you have that. Let's take a look at example 2. Now, first of all, I have a binomial, and you should be saying, all right, this is really easy to factor if this binomial is the difference of two squares. Is it the difference of two squares? Is 49 a perfect square? Yes, 7 times 7. Is m squared a perfect square? Yes, because m times m. Is a squared a perfect square? Yes, a times a. So this is the difference of two perfect squares. And the difference of two perfect squares always splits up into, or factors into, a plus and a minus. All right, what's the, now I take the first term. What times itself is 49? 7. What times itself is m squared? M. And notice these are tied together because they're tied together right here, so they're tied together. So I put a 7m at the beginning of the other one. Now let's do the a squared. What times itself is a squared? Well, a times a. Now if you FOIL this, you're going to find out that you get 49m squared minus a squared. Let's just go through one more FOIL to check it. Let's see, multiply the first term, 7m times 7m. 7 times 7 is 49, m times m is m squared. Multiply the very outermost terms. 7m times a negative a is a negative 7ma, or am. Multiply the inner terms, a times 7m, positive ma. And finally, multiply the last term in each, a times a negative a minus a squared. And again, these cancel out, and I end up with 49m squared minus a squared. So it checks. Example 3. Notice here I don't quite have the difference of two perfect squares. I know that 36a squared is a perfect square, 6a. I know that 25y squared is a perfect square, 5y times 5y. But do I have the difference? Well, you know what? I don't, but I can rearrange this. I could write this as 25y squared and then the minus 36a squared. Now I have the difference of two perfect squares, which always factors into a plus and a minus. Okay, what's 25y squared break into? Well, that breaks into 5y, because 5 times 5 is 25, and y times y is y squared. So the first term here is the first term in each of these. And what's 36a squared break into? Well, 36, what times itself is 36? 6. And what times itself is a? A squared, I should say, a times a. And I'm done. All right, last example I have is similar to the last one, except we have a little bit more involved with the first term here. Now I'm going to rewrite this so that I have the difference of two perfect squares. And I know that everything that I have here is a perfect square. 49 is, a squared is, 36 is, x to the 6 is, because x cubed times x cubed. And finally, y to the 4th is a perfect square because y squared times y squared is y to the 4th. So this breaks into a plus and a minus. Right, so the let's see, what would I have for the first term in each of these? Well, what's 49, what times itself is 49? 7. What times itself is a squared? A. So that's what I have in the first term of each. Now the thing that's a little different is the second term. All right, what times itself is 36? 6. What times itself is x to the 6? X cubed, right? Because x cubed times x cubed is x to the 6. You add the exponents. And finally, what times itself is y to the 4th? Y squared. And if you FOILed this, you would find out that it checks out. So this is called factoring the difference of two squares.